Three pillars of knowledge. A successful data scientist needs to have a strong technical background in data mining, statistics, machine learning. The in depth understanding of modeling with insight about data enables a data scientist to convert a business problem to a data science problem. Many chapters in this course are focusing on analytics, knowledge, and tool sets. Domain knowledge and collaboration. A successful data scientist needs in depth domain knowledge to understand the business problem well. For any data science project, the data scientist needs to collaborate with other team members, communicate, and leadership skills are critical for data scientists during the entire project cycle, especially when there are only one data scientist in the team. The scientist needs to decide the timeline and impact with uncertainty. Big data management and new IT skills. The last pillar is about computation environment and model implementation of big data platform. It is used to be the most difficult one for a data scientist with data statistics background. I lack that is lacking in computer science knowledge or programming skills. The good news is that with the rise of big data platform in the cloud, it is easier for a statistician to overcome this barrier. The big data cloud platform will describe this pillar in more detail. The very first problem internet companies face is that a lot of data has been collected and how better store this data for future analysis. Google developed its own file system to produce efficient, reliable access to data using large clusters of commodity hardware. The open source version is known as Hadoop Distributed File System. Both systems use MapReduce to allocate computation across nodes on top of the file system. Hadoop is written in Java, and writing MapReduce jobs using Java is a direct way to interact with Hadoop, which is not familiar to many in the data and analytics community. To better use the Hadoop system, an SQL-like data warehouse system called Hive and a scripting language for analytics interface called Pig were introduced for people with analytics background to interact with Hadoop system. Within Hive, we can create user-defined functions through R or Python to leverage the distribution and parallel computing infrastructure. MapReduce on top of HDFS is the main concept of the Hadoop ecosystem. Each MapReduce operations requires retrieving data from hard disk, then performing the computation and storing the result into the disk again. So on top of Hadoop, jobs require a lot of disk operations, which may slow down the entire computation process. Spark works on top of the distributed file system, including HDFS, with better data and analytics efficiency by leveraging in memory operations. Spark is more tailored for data processing and analytics, and the need to interact with Hadoop directly is greatly reduced. The Spark system includes an SQL-like framework called Spark SQL and machine learning library called MLlib. Fortunately for many in the analytics community, Spark also supports R and Python. We can interact with data stored in a distributed file system using parallel computation across nodes easily with R and Python through Spark API and do not need to worry about the lower level details of distributed computing. We will introduce how to use R notebooks to drive Spark computations. Even though Spark provides a solution for big data analytics, the maintenance of the computing cluster and Spark system requires a dedicated team. Historically, for each organization, the IT department owns the hardware and regular maintenance. It usually takes months for a new environment to be built, and the cost is high. Luckily, the time to deploy and costs are dramatically reduced due to the cloud computation trend. For beginners, Databricks provides an easy to use cloud system for learning purposes. Databricks is a company founded by creators of Apache Spark and provides a user friendly web based notebook environment that can create a Spark cluster on the fly to run R, Python, Scala, or SQL scripts. We can use Databricks' free community edition to run demos of this course. Please note to help readers or students to get familiar with the Databricks cloud system. The content of this section is partially adopted from databricks.com documentation.